All right, I wasn't able to. I'm not able to show the magnet going down through the copper tube. Uh, Looking down through it. I'll look for a video online already made, but it needs another pair of hands because I need to put a flashlight down in there because it just is black. So we'll just have to do it kind of a boring way. Here is the magnets with a PVC pipe. Of course, it doesn't react, and we can just see it just goes straight down. I don't know if you heard it drop there. Maybe I should cut the music, but it went straight down. Okay. Now we'll do it with this. Again, it's copper tube. It is a copper tube, so there's no reaction. These are the super strong magnets. So of course they wouldn't go like that. So now if I drop it through here, oh, it got stuck at the very bottom. There it goes. Goes very slowly through. Let's try it again. See, it's stuck in that same spot, and then it drops out. So it's very slow to go through. That is due to Lenz's law. As the magnet is falling, we can think of this as being infinite number of rings. So if this is the North Pole down, then this will attract, because the strength of the field is changing through this ring, there is a change in flux. So Faraday's law tells us that will induce a current. Lenz's law tells us that current will be opposite the change of flux. So as the North Pole is going downward, it will induce a North Pole upward, and those two poles repel themselves. And that slows it down as it drops. All right? I hope you enjoyed these videos, and see you.